There you go. Yeah, good morning or good afternoon, everybody. My name is Jay Torres. I work with Pacific Systems Group, and we are the carrier VRF and mini split rep here in California. We cover Hawaii as well. And yeah, today we were going to go over some VRF updates, talk about uh, the A2L transition, and we'll briefly cover carrier's VRF offering. See, everyone can see the screen, right?
Yeah.
All right. Cool. All right, let's get started. Yeah, so here's the agenda. Talk about VRF. We'll talk about the basics of VRF. Difference between two-pipe and three-pipe heat recovery. We'll go over Toshiba Carrier's VRF offering, as it's pretty unique to the industry. And at the very end, we'll talk about A2L refrigerants. We'll talk about HRI ratings for VRF and how they've updated that testing method. And then we'll go over a sample project where we're using a simple VRF system using an A2L refrigerant, and kind of go over the design, and we'll show that, even though we are in this transition to A2L refrigerants, it's not as scary as it may seem when the announcement was first made. So we'll go over all that at the end. But first, VRF basics. I take it everybody has heard of VRF, knows what it is generally. But for those who aren't quite as familiar, just real quick, VRF stands for variable refrigerant flow. It's basically a heat pump, right? It's got an outdoor unit and an indoor unit. The thing that makes it special is that you can connect multiple fan coils to one outdoor unit. You can do long line lengths. You can do simultaneous heating and cooling with the introduction of a flow selector box. We use VRF because it's very efficient. We can get precise zone control because we can place a fan coil into each zone. We can do all the way up to 74 fan coils on one outdoor unit, depending on the size of the outdoor unit. Lots of different fan coil options that we'll go over. Heat recovery, like I mentioned, and then inverter control gives us the efficiencies. We use inverter compressors, and we use EC fan motors on all of our indoor fan coils. I like to show this slide just to show kind of schematically the differences between two-pipe and three-pipe heat recovery. So on the left, we have a two-pipe system. You can tell by there's a two pipes going from your outdoor unit going into the MDC box, and then on the two other examples on the right are three-pipe heat recovery systems. On the left, two-pipe system, you've got one big MDC box, and then you've got refrigerant lines going all the way to your different fan coils. On a three-pipe system, same idea, three refrigerant lines coming from the outdoor unit. One of the things that we get asked all the time is, where would we use two-pipe, where would we use three-pipe? What type of application would dictate one design versus the other? Generally speaking, a two-pipe system, we like to use those for maybe low to mid-rise office buildings, or any building where you've got maybe a large central location. It's not rectangular, it's more or less square, where you can place one of these boxes centrally, and then say if there's like offices around the perimeter of the building, you can then pipe from your box all the way to the different fan coils. These things are a little bit large compared to the three-pipe, the flow selector box compared to the three-pipe. So generally you want to place these centrally and then branch out. Three-pipe heat recovery, we have a little bit more flexibility as far as the flow selector boxes. They come in single port boxes, and we also have 4, 8, and 12 port varieties. This allows us to kind of strategically place these flow selector boxes wherever we need to in the space. So like in a hotel application or like a mid to high rise office building, you can strategically place these on different sides of the building or different corners of the building, and then you can pipe out and zone to the different fan coils. This is just showing that we can do single port boxes. When I give this presentation to contractors, they absolutely freak out because no one wants to hang each individual single port box with a fan coil, connect all those pipes. But for some applications, I would argue that this could be a good design, like for like a hotel, right? Each hotel gets its own fan coil. Ideally, give it its own single port flow selector box. So if something were to happen, or if like a maintenance person needs to access one of these fan coils or a flow selector box, on these multi-port flow selector boxes, you would have to take down some of the other fan coils. But if a fan coil has its own flow selector box, you're not necessarily taking down other fan coils that are connected to it. So just an overview of 2-pipe versus 3-pipe. Any questions on how this looks schematically before I dive into our product offering? No questions, right? All good?
Just something real quick that I would like to jump in on that too.
Yeah.
Especially if you guys don't know where to put flow selector boxes, or you guys need like rough refrigerant charges. This is something that if you guys just send me floor plans, tell me where fan coils are, or where the condenser, I can run the pipe links for you guys. And something I can do is run 2-pipe and 3-pipe to figure out which is cheaper, or which is the better option in that case. So if you guys have any projects like that and you're just unsure, that's you just let me know, and I'll send you the mechanical plans with all the like rough refrigerant piping laid out.
Yep.
Excellent.
And Renee kind of alluded to 2-pipe and 3-pipe. So Carrier is unique in that we're the only manufacturer that provides both a 2-pipe and a 3-pipe heat recovery system. So typically you have 2-pipe, that's Mitsubishi and Carrier branded, and then pretty much almost everybody else on the heat recovery side is 3-pipe. So Daikin, LG. We have our Toshiba Carrier line, and then I'll go over briefly our product offerings as far as our 2-pipe and 3-pipe. So what you're looking at now is our Carrier 2-pipe heat recovery system. It's Carrier branded. It's got the blue oval. We have single phase, 3, 4, and 5 ton heat pump only, so cooling or heating, and then 5 ton. Our 3-phase offering, we go all the way up to 28 tons on our heat recovery. All around it, you see the different fan coil options. So every fan coil style you can think of: ductless, ducted, medium static, high static. We even have an outside air fan coil, vertical or multi-poise, and then the different ductless options: high wall, 4-way cassette. They come in 2 sizes. Ones that'll fit in the T-bar, and the larger tonnages are 33 by 33. And then one real quick thing I want to point out on our Carrier 2-pipe heat recovery system is our outdoor units. They're pretty unique in the industry. You'll see that they come in a small, medium, and large module. Pretty much everybody else, when you go to the higher tonnages, they take like a 10, 12, or 16-ton condenser, and you pair them, or you get 3 of them, and you pair them together, and you get to your higher tonnages, right? On Carrier 2-pipe heat recovery, they come small, medium, large modules. So for example, in our large module, 20 all the way up to 28 ton. So these come like this from the factory. The advantage of doing it this way is that the contractor or the installer has less work to do out in the field. They don't have to pipe 2 or 3 modules together. They don't have to run electrical to 3 individual modules or condensers. The advantage here is that there's time saved. You don't need to pipe them out in the field, and they only require 1 electrical connection because they come like that from the factory as 1 module. So less time for the contractor, for the installer to install these, and that's unique on our Carrier 2-pipe heat recovery line. Moving to our Toshiba Carrier offering, it looks very similar to our Carrier branded line. Same thing, 3, 4, and 5 ton single phase for your light commercial or some residential applications, and then we have our 3-phase all the way up to 42 tons on our heat recovery. And then a lot of the same fan coil options are available, ducted and ductless. 2 things that are not, or 1 thing that's not pictured on here is our DX or PMV kit. So if you have a third party or a Carrier 39 series air handler, if for some reason one of these fan coils does not fit the application, like say you've got a high school gym where you want to condition it, and it's a higher CFM than our largest fan coil, which is 8 tons. You can use, say, a 39 series air handler, use a PMV kit. We would provide a custom DX coil that would go inside that air handler, and then you would just pipe it to our VRF outdoor unit, and then you can use a third-party air handler with a VRF system. And then last thing I want to point out on our Toshiba carrier line is our rooftop fan coil. We call it our 40QQ. It looks like a standard carrier rooftop, and that's because it is. It started its life as a standard carrier rooftop, but we took out the condenser coil, we took out the compressor, we took out the condenser fan. Oops. And we left the evap coil and the evaporator fan in there, and what that allows us to do is connect these to a VRF outdoor unit. Where would you use one of these? So say, for example, I am an owner of a strip mall. I've got rooftops cooling my strip mall, but now I want to, it's 20 years old, I want to upgrade, but I want to maybe do something a little bit more efficient than a standard rooftop, but I don't want to do too much to my building. I don't want too much downtime for my tenants. You can use one of these 40QQs. So one of the great things about these is that since it uses the existing carrier rooftop, it's the same footprint that Carrier has been using for decades now. So if you have existing rooftops, you can just take those off. You can use the existing roof curb. You can use the existing ductwork. They're a lot lighter than the existing rooftops because there's half the rooftop is gone, right? There's no compressor, no condenser equipment, and then you can use a lot of the same accessories as a carrier rooftop. So economizer for ventilation or using free cooling when conditions allow for it. You can use these for heat recovery. You can see there's the 3 holes there on the side of the panel, on the side of the unit. So just 3 pipes into there. You can install the flow selector box, like a single port box, inside one of those things. And now the building owner has an updated system, has a more efficient system since it's using VRF. Something that Sigler is doing in partnership with Wills Energy, they're a third-party manufacturer. They have a custom version of this that goes up to 10 ton. So these go up to 5 ton directly from the factory, but if you have an application where you need 6 all the way up to 10 ton, we have this available. There's actually one in our training center here in Brea that you can take a look at. But yeah, just wanted to point those 2 things out on the Toshiba carrier side as it's unique to our offering on the Toshiba carrier side.
If I can mention something here as well.
Yeah.
I'm not sure. Do you guys do a lot of schools? I can't remember. You guys do schoolwork or?
We've done some
schools.
not that much.
Okay, so like there's a few projects. Maybe I think it's 2 or 3 school districts, or 2 or 3 schools, and they were looking for something more efficient. But there's already a lot of rooftops on top. And there's like a evil like entity called DSA, right? that have to do with schools,
Yeah.
the structural. Well, they love this because you don't have to touch the roof at all, especially with how much weight you're removing. So this is like just another point. We've seen this pretty frequently. Like we've worked on projects with schools with these units, and you avoid DSA altogether. The school loves it, and the engineer loves it because you don't have to deal with weight or be heavier. Yeah.
And then lastly, on the Toshiba carrier side, I just wanted to highlight our flow selector box. So we just completed a transition from our E series to our U series. So we went from single port, 4 port, and 6 port. Now we did away with the 6 port. Now we have an 8 and 12 port. Another improvement that we made with this series of flow selector box, they no longer require a condensate drain. So we got rid of that requirement as well. But yeah, single port 4, 8, and 12, we have the ability to connect all the way up to 12 fan coils on our 12 port. And then as far as controls, we have a lot of different ways that we can control and monitor these VRF systems. By default, this is a controller that ships with fan coil or with our systems. But if you want to use something else like a third-party thermostat, Nest or Ecobee, we have a 24-volt interface. So at any third-party 24-volt thermostat, you can connect it to one of our systems. I don't know if you all do hotel work, by any chance? Just want to highlight verdant controls. So if you have a hotel, or let's just say you want to go this route, one of the highlights of the verdant is that these do not require this 24-volt interface. It directly interfaces with our fan coils. So if you're looking at a hotel or maybe just any project with multiple fan coils, take a hotel example, like 100, 150 rooms times $200. I don't know how much these go for the contractor. But if you do the math, that's a lot. You can do away with that and then integrate with verdant, and it has all the stuff that hotels look for as far as occupancy, integration with door locks and lights, just to know when to set back set points if the guest is not in the room. So we have that, and then of course central controllers and backnet interface if you want to monitor and control third-party equipment, DOAs, VRVs, lights, etc. Okay, any questions about our product offering before I dive into the next section? All right, cool. So last section, talking about AHRI regulations, A2L refrigerants, and the new testing methods for testing VRF. So AHRI, they test all types of equipment for efficiency ratings. They updated the standard for how to test VRF systems in 2023. Basically, what they did was the way the system, the equipment comes off the line is how it has to be tested. Controls cannot be altered. The unit will have to run as it would in the real world. And what we noticed was that some of the other manufacturers were kind of tweaking their control algorithms, trying to eke out the best performance. I always use the auto industry as an analogy. Do you guys remember Volkswagen and Dieselgate? They got slapped on the wrist for kind of tweaking their efficiencies just to meet certain levels. What the new 2023 standard did was it leveled the playing field. You're not able to tweak how your equipment operates. It has to be the way the customer gets it out in the field. And what we did was we took some of the efficiency ratings from the previous method and compared it to the new method. And you'll notice some pretty interesting things that happened as far as the efficiency ratings. A lot of them went down when you compare it to the previous method to the current method. If you look at it as a percentage, some of the percentages, as much as 30% efficiency drop with the new testing method. And then if you add in our Toshiba carrier line, how it looks compared to the rest. So on the left, we have our standard model. We also have a high heat model for cold climate areas. You'll see that Toshiba carrier has a lot of green in their column. So this is 95 EER with ductless fan coils, and then this is with ducted fan coils. It looks very similar. There's a lot of green in the Toshiba carrier column. And then if you look at COP at 47 and then at 17 degrees, there's a lot of green in our column as well. All this to say, this is all public information. You can go on the HRI website. But all this to say is that Toshiba carrier, we have the most efficient VRF system on the market. Okay, let's talk about refrigerants. We all know we're in the middle of this refrigerant transition to these new A2L refrigerants. For VRF, EPA tells us we need to use a refrigerant that has a GWP global warming potential of 750 or lower. This just came out, so for 510s and above, as VRF manufacturers, we have until the end of this year to bring in as much equipment before the deadline. And previously, we had a year sell-through, so whatever equipment that we had here, we would have a year to sell and install. But the EPA actually gave us an extra year to sell through our existing equipment. So now we have until January 1st, 2028 to bring in and install 410A VRF equipment. So here's some common refrigerants that are being used and their GWP. 410A has a GWP of over 2,000. The majority of VRF manufacturers are using the next two refrigerants, R32 and R454B. I know a lot of our competition is using R32. Most, the reason why they're using R32 is because they already have this equipment in Europe and in Asia. They're already using it. They already have systems that use R32. So all they have to do is bring it over here, get it UL tested, and they can sell it in the North American market. We always get asked, why did we carrier choose 454B when everybody else is using R32? We're kind of hedging our bets. We don't know if what will happen in the future, but if the EPA makes another switch or mandates that we use a different refrigerant that has a better GWP rating, if that number happens to be 500, we'll be okay. We don't need to make another transition. We don't need to re-engineer equipment. We don't need to train customers on new model numbers, etc. So if that time comes, the other manufacturers have to scramble and re-engineer new equipment. But we've already done that work if that change were to happen. So we're kind of hedging our bets when using 454B. All right. With these new A2L refrigerants, we have to be concerned with their slight flammability, right? So A2L means they're not toxic, but slightly flammable. So with ASHRAE, we have to look at not just RCL now, which stands for refrigeration concentration limit. We have to worry about LFL, which is lower flammability limit, since these refrigerants are slightly flammable. So RCL is based off of LFL. So if you remember, for R410A, it was 26 pounds per 1,000 cubic feet. Since we do have to worry about their displacing oxygen in space, they are slightly flammable. So those two numbers for R32 and R454B are a lot lower compared to 410A. So just something that we have to think about when designing VRF systems for projects is these numbers are a lot lower. And then as far as single phase equipment, 5 tons and below, that equipment is already here on shore. We're selling it and we're installing it now. On the Toshiba carrier side, you're dealing with the new equipment. It has the B in the model number. And then just going over some of the changes, some of the improvements.
Yeah. We got a question.
Yeah.
What's the current price difference between the R32 and R454B?
So I'd have to have pricing for the competitors. I don't have that. There is, I think, across the board, there is a little bit of a price increase compared to the previous 410A models. I don't think it's that much, but I know there is there's new hardware that we have to introduce. There's a leak sensor, leak detector in all of our fan coils, so that's accounted for in that price increase. But if you compare 32 and 454B, the other, I don't have that information, unfortunately.
So kind of like just talking on what we're offering from R410A to R454B. Yeah, there has been a price increase. Some of it being due to new components, like you said, like a leak detector and even like special alarms now, I think you go over. But yeah, so there's that, and then the refrigerant changes, things like compressors. So there's a price increase in that case. But yeah, I'm also not too sure what the price difference really is between like us and Daikin or us and
I wouldn't have that information, unfortunately.
But yeah, I mean, even that, if you guys ever wanted like some sort of budgetary price, even if it was like you wanted it, because that's what sometimes drives projects, right? Especially with an owner. I can always work up some sort of budget number. So yeah, that's kind of more project specific though. So yeah, just.
Yep, good question. So for our single phase, what has changed? So main difference is on our.
Oh, 1 sec. I think Nate, are you talking? Sorry, I don't know. Oh, I can hear you now. Yeah. Sorry.
So my question was mostly more like it's from a serviceability standpoint, just looking at like in the future, when these pieces of equipment need serviced, is that do you guys know if there's a market difference in between like a contractor going out and servicing a piece of equipment that's on 32 versus them recharging a piece of equipment using R54B? start to phase out equipment like more than likely R10, R410A here soon is going to jump the price because it's going to be hard to come by, it's going to be hard to get, things like that. So I didn't know if you guys knew, and just from a serviceability standpoint, if there's a cost difference between those refrigerants. Not necessarily your guys' cost versus IT cost or whatever, but more like from a contractor going out and servicing that.
Yeah, from what I've heard going into contractors' offices is that 454B is a little bit difficult to get a hold of right now, and I think that's understandable at being a new refrigerant that is being introduced. And yeah, the cost is from what I've heard a lot more. I don't know what percentage or the magnitude, but I do hear it's a big pain point right now for contractors. I would guess that as we move further along in this transition and more 454B is available, it is a blend of 32 and 1234 YF, I believe. So as we're able to produce more of this refrigerant, I see the cost of it going down. But as far as right now in July 2025, what I'm hearing is that yes, there is a cost for 454B, and it seems like it's a supply-demand thing where there's not enough supply for the demand, and that's why the price is going up. But I'm pretty sure we'll see the prices come down as things get shaken out, there's more production, and it's more readily available. Hope that answers that question. For Toshiba Carrier single phase, we've made some improvements with the new version. One of the things we want to point out, piping lengths. So we almost doubled the total amount of pipe that we can use from 591 feet to 984 feet, so almost doubled. And then the furthest piping length, so from your outdoor unit to your furthest fan coil, we made some improvements there as well. We also were able to use a single fan chassis on all of our tonnages, 3, 4, and 5 tons. So previously the 5 ton was about this high with the dual fan chassis. Now they're all single fan chassis. So if you have an application where, say, residential, and you want to place it in front of a window, you can now place it underneath the window, it won't block the view, just a little bit more options as far as installation. Efficiency improvements, so you can see on our 3-ton, 27.37 CO2 rating, but pretty much almost across the board, we were able to get some efficiency gains with our 454B version. Now, with the A2L refrigerants and some of the issues that we have to deal with in terms of flammability and making sure occupants are safe, we introduced this SV box, solenoid valve box. So for systems, especially on our single phase where you have multiple fan coils, long refrigerant line lengths, where the potential for a leak to occur and dump all that refrigerant into a space, depending on ASHRAE compliance, we may need to introduce these SV boxes to help mitigate the amount of releasable charge. I do want to stress that you won't necessarily need one of these for every project, but for those projects where you've got multiple fan coils or a lot of refrigerant in the system, this is one method for helping to mitigate releasable charge into a system. It's outdoor installation for now, but we are coming out with the 2nd generation version that you can install either indoor or outdoor. And all the logic is built in. Like I said, we have leak detectors on all of our fan coils, so that's already built in. And we have the logic built in to our system. And this is how the control logic would work if the sensor detects a leak. It would tell the outdoor unit to shut off its compressor so it's not sending more refrigerant into the system. It would tell the SV box to close its valve. So any refrigerant from the box to the outdoor unit gets cut off and it potentially does not leak into the space. And then it will tell the fan coil to continuously run its fan to help dissipate the refrigerant in a space. Yeah, so that's how that works. As far as our carrier branded single phase, it looks very similar. Unfortunately, the 510 is still a dual fan chassis, but we still have the same SV box, serves the same function as our Toshiba carrier, but it is available on our carrier line if we need to help mitigate releasable charge into a space. As far as availability, all this product is available now. We made these slides a couple months ago, but all of our single phase 454B equipment is here or on its way here. And then for our 3-phase, we are going to start bringing that stuff in by later on this year for our Toshiba carrier, and then next year, early next year, to the middle of next year for our carrier branded VRF systems.
Yeah, and then just jumping in there real quick, have you guys already started like having to calculate the hash rate 15?
Yeah, a couple of projects, yes.
Yeah, so yeah, Jay's gonna get more into it too, but this kind of like releasable charge is what you calculate. Now, the way it's been right now is releasable charge is everything. But really what's special about the SB box is the reason it drops its refrigerant so significantly right after the condenser is because most of the refrigerant is going to be at the compressor. So you're cutting off the whole algorithm. You'll usually pass after that, but yeah, Jay will get into it. We also have some calculations in the software where it'll help you out figure out like A-man and stuff.
Yeah, so we have a simple example system that we want to go over, but before we go over that, just to get some terminology out of the way so we know what we're talking about. RCL, we talked about a little bit. It's the refrigeration concentration limit. We use that to calculate our minimum area volume. Effective dispersal volume, that's basically length times width times height. Effective dispersal volume charge, or EDVC, this is the formula that helps us calculate the maximum refrigerant charge permitted for a given volume. So the equation is EDVC equals LFL, which we can get from those ASHRAE tables. It's for 454B, it's 0.0185 pounds per cubic feet. And then you multiply that by your effective volume, and then you multiply that by two constants, your occupancy factor and your concentration factor. For occupancy, it's going to be 1, and then for concentration factor, it's going to be 0.5 for institutional, so hospitals or assisted living, anything that's 24/7 operation, and then it's going to be 1 for everything else. So let's look at an example system. We have a simple office building with different rooms, footprint of about 2,000 square feet, 40 feet by 50 feet. We're assuming 10-foot ceilings. And we're using a 5-ton VRF outdoor unit with a 5-ton ducted indoor unit that is installed above the ceiling space. And since we are using open return, we can actually include that interstitial space above the ceiling, so about 2 feet in this example. So our total height would be 12 feet. If you do the math, you get effective dispersal volume of 24,000 cubic feet for this example. Like I said, we're using a simple 5-ton VRF system. So this is one of our carrier mini VRF single-phase systems. So outdoor, indoor, about 40 foot of refrigerant line set. And this is what our software actually generates for us, for you folks who are designing VRF systems. If you give us the refrigerant line length, we can calculate how much additional refrigerant we need to add to the system. So for this particular system, we need to add 1.44 pounds. So that gives us a total refrigerant amount of just under 10.5 feet, 10.48 pounds. All right? So if we go ahead and look at our space, we have a total refrigerant charge of just under 10.5 pounds. We have the LFL of R454B. And if we plug in all of those numbers, we get 22.2 pounds for the space. Since 10.48 which is a total refrigerant charge, is less than 22 pounds. Based off of the EDVC calculation, this system would comply with ASHRAE section 7.6. So we didn't need an SV box. This is just a VRF system with a one-to-one system, and it passes. We don't need any extra provisions for an SV box or anything like that. But we're not going to always have simple systems like that. If we do need to introduce an SV box, we have software that helps us calculate and lay this out for you. So our software is called vPro. If you have an application where you do have an SV box, our software will actually help us calculate the releasable charge, which is the number that we need to figure out to make sure this complies with local code or ASHRAE. So what that does is our software will ask for your smallest, the dimensions of your room, and then based off of all those parameters, if we plug everything in, our software will tell us the minimum room volume that's allowed, given the amount of refrigerant in the system, and it'll give us the minimum area for either a commercial or residential application, based off of ASHRAE 15 or 15.2. So all this to say that this transition at the very beginning seemed scary, and we didn't know much about how we were going to design systems using VRF. But now that we've looked at the code a little bit more closely, and we see that not necessarily everything needs an SV box, it kind of put us at ease. And for the applications that do need this, we have the software and the tools that will help you design VRF systems using these new refrigerants. So that is my last slide. Do we have any questions that have come up during this time?
For example, that 2,000 square feet office,
Yeah.
right? We're allowed to have 22 pounds of refrigerant, right?
Yes.
Then we have 10.5 almost.
Right.
So we comply with ASHRAE 15.
Yes.
Right? Let's say this 2,000 square feet is a restaurant,
Okay.
and we need like 15 ton, and we end up with like 30 pounds, our actual system.
Okay.
We don't comply with
Right.
ASHRAE 15, right?
Right.
Will the SV box solve that issue?
Yeah. So we would, if that were the case, we would go back and we would see we wouldn't comply, and then we would place an SV box. Depending on the building, we can figure out where it needs to sit in between the outdoor and the indoor, and then our software, depending on where it sits, would calculate, okay, if it's here, we only have, say, I don't know, just say 25 feet from the box to the fan coil. So now the software will tell us, this is how much refrigerant would potentially leak with this SV box in place, and then we can figure out if it's less than whatever, 22.2 pounds. So yeah, if it doesn't comply, then that's where we would go back and put the SV box where it needs to go, and then we can calculate releasable charge, and then figure out if it complies or not. If that
Based on the length of
Based
the
on the
sample line.
Yeah,
Right?
yeah. So, if we placed it closer to the outdoor unit, we may not pass because there's still all of that refrigerant in that pipe. But if we install it as close as possible, then you mitigate a lot of this refrigerant in the outdoor unit, especially. And then the piping length all the way up to the box. So yeah, it really depends on where you place it. It could change.
Quick note on that too. So our VRF systems that are coming out with our 454B, at the flow selector box, let's say it's an 8-port, each port is a valve. So like your releasable charge is only from the flow selector box to the fan coil. So that's a big thing, because let's say it is a restaurant, and let's say in this case you're going to use a 20-ton VRF instead of multiple pipes. If you use that 20-ton, at the flow selector box or at those boxes have what we're talking about here already, like installed.
So when our 3-phase 454B product is introduced, these flow selector boxes, not only will they help divert refrigerant where it needs to go, but these will have those valves built in to help mitigate releasable charge. So we're not going to need a separate SV box in the single phase VRF version because we're going to build in those valves at our flow selector boxes. So these will gain the capability to shut off the flow of refrigerant and then help mitigate that releasable charge. And then, yeah, like I said, all of our VRF fan coils have the leak detectors built in. All the logic is built in, so if something were to happen, it would tell whichever port to close, fan would run, outdoor unit would shut off. So I think it would be it's going to be easier on the three-phase side because we have this for heat recovery also because we have these flow selector boxes that have the valves built in. So it's going to be even less of an issue, I think, on the three-phase. Any other questions? Is there anything else online?
Yeah, funny note on that too. I believe the way it's gonna work is if it detects a leak, it'll shut off for 5 minutes or 10 minutes, and then it'll turn back on. So it'll do that 3 times before it's a hard shut off, and then it requires servicing. So it's just funny because if it's really like that dangerous, why is it turning back on after the first leak detection? But that's like per code, so that's how that's gonna work.
Any other questions?
Yeah, Nathan.
Yes.
I have my mic up. Yeah.
Can you guys hear me?
Yeah, we can hear you.
Okay. Yeah, you had a slide up there that showed the different heat pumps based on tonnages. I was just see if we can go back to that and talk about it real quick. I guess my question is, yeah, this one here. So the first one from 6 ton to 10 ton, you're showing a single compressor, and then from 12 to 22, from 20 to 28, 3. Are you guys utilizing the same compressors in all these? And if so, what are the turn down capabilities of them?
Yeah, we're using the same compressors. We can turn down pretty low. I don't have that memorized off the top of my head, but we can go down pretty low as far as turning down. So if you have like a minimal load on just one zone, we can turn down and serve that space. We can look that up as far as the percentages that we can turn down to, but we can turn down pretty low.
Yeah, that's.
Sizing off the system, we have multiple indoor test sets, looking at the lowest load scenario. It'd be nice if we have this chart right here with like a turn down percentage, so that we can make sure that particular unit that we're selecting is going to be able to turn down to the lowest load that we have on the zone or out of the zones that we're connecting it to.
Yeah, that's. I'll look into that and I'll get back to you on that and get you like a hard number if there's a hard percentage that we published.
Okay, great, thank you.
Any other questions? If not, I just want to thank you all for your time. Renee, do you have any closing words?
I guess just real quick, have you guys been seeing a lot of VRF projects coming up? Or I know for a little while engineers were getting scared and they're like, we're going water systems again. We don't even want to deal with this, but it doesn't seem that bad now that we're kind of getting into the actual ASHRAE verbiage coming out and people now commenting on it. So it doesn't seem that bad. Or have you guys been getting a good amount of VRF projects?
We've done a lot of VRF system. Like it's to us to decide what system we gotta use, and whenever we see like the VRF is the best, the most efficient system to go with, we just go with it.
Okay.
Yeah, especially when we have like fan coils more than 3 tons. So we go with VRF because it is like much more efficient, and then we can remove the economizer.
Yeah.
Right.
Yep.
So
Yep.
that's
It's
mostly
efficient
it.
enough.
Yeah.
Yep.
So yeah, we're not afraid of VRF.
Yeah, I'm
That's
glad. I know someone was like, oh, we're going back to chillers and 40 hydronic fan coils, and I'm like, yeah, like they're just scared of beer. But that was like when it was just coming out. And even then, they're like, all right, it's not that bad. And there's a lot of solutions, like Jay went over. It's not really gonna be an. I don't see like, yes, there's probably gonna be a few projects, but for the most part, I don't see a project changing its entire design because we couldn't meet the hydrate code. Like we can introduce boxes,
Yeah.
and
You could split them up into different smaller systems.
yeah,
Also,
so
if you want to stick with VRF.
yeah, so that's good to know that you guys are continuing with this here. Yeah. Cool. All right. Yeah, I thank you guys for joining us as we kind of go over these changes, and as always, if there's any other changes coming up, whether it's VRF or anything else, we try to stay on top of it. So we'll continuously stay in contact with you guys and see if you guys are ever open for another lunch and learn. In general, even if I'm not reaching out, if there's anything you guys want me to go over, if it's, hey, we're kind of confused on X, Y, Z, would you do a lunch and learn on it? Or we kind of want to learn more about X, Y, Z, just let me know. I can always put together any sort of lunch and learn together, and we can set something up. But
So much.
cool. Thank you guys.
Thank you.
See you.
Awesome. Thanks, Renee. Appreciate it. Thanks, Jay.
Thank you.
Thanks, Jeremy.